Hi there, welcome back. Today we're going to look at section 1.3. We're going back and look a little bit at using functions and representing them in models with business and economic terms and applications. So we're going to be writing functions based on the real world problems that we're given. And in math, this is called mathematical modeling. So today, what we're going to do is, first off, make sure we recognize and understand the business and economic terms, total cost, revenue, profit, functions, and break-even points. Then we're going to create and evaluate these functions, these mathematical models for business applications. And then lastly, we're going to look at what's called market equilibrium. Okay. All right. So some concepts that you guys need. It's typically the problems are pretty straightforward, but the biggest part about this, as always with word problems in students, is understanding what represents what. Okay, so in business concepts, in these problems, and you're going to see them again in section 2.9, you need to be aware of the function notation as well as what they represent. So for number one, revenue, R of X, says R of X equals the number of items or units sold times the selling price per item or per unit. Okay? Then they give you the formula in terms of the function notation for revenue, but still using the words. Okay, so again, R of X, that means revenue, equals the number of items sold times the selling price. And here it says where X commonly represents the number of items or units sold. So up here where we have just the definition, I wrote the number of items sold is typically the X that you're going to have. And then the selling price per item or per unit is either given to you with the word price, which we use a lowercase p, and we'll learn in just a minute about D of X, which is the demand. Those are both the same thing if you're plugging them into this formula. Okay? So it says, when the selling price is not constant, which happens a lot. Sometimes things change in businesses. It's not always a fixed rate. So when the selling price is not constant, we often have that R of X equals X times D of X. Now remember, X is the number of items sold. D of X is the same thing as the price, but we write it as D of X because it's the demand price. You know, depends on how many are being sold, maybe as what the price is going to be. So that's when it fluctuates. So please remember that when you're doing the revenue, you're always taking the number of items sold times the price at that time. Sometimes the price is just going to be given to you as a number, but sometimes they're going to give you another function, D of X, which is telling you that the price fluctuates. It's not always constant. Okay, so keep in mind, I wrote this over here, little p, not capital P, but little p is price. That's the same thing as the demand function D of X. Okay, those are one and the same. So when we work these problems, I'm going to probably write it like this because sometimes we still are not comfortable with the notation yet. It doesn't matter how you learn it, just make sure you understand that revenue is the number of items sold times the selling price, okay? That's what you need to remember. All right, so it says down here, I already kind of talked about it, but number 2 says the selling price per item can be a fixed number. Typically, if it is, it'll give you that, but often it fluctuates based on market factors. So in this case, the selling price is represented by the demand, D of X, okay, or P. So those are the same thing. Got to get used to that. Okay, so once we have the revenue, we know how to find that. Let's look at the cost. All right, when you see cost, that's the manufacturing cost it takes to produce the item, not the cost for the buyer, not for whoever's buying the product. So when we're talking about cost in these problems, it is the cost of manufacturing or producing the product. We use the function notation C of X to represent the cost function. Okay, and C of X equals the manufacturing cost per item let me say that again, it equals the manufacturer cost per item times the number of items produced. Okay? Now, the number of items produced. So all of that is V of X. And I don't typically use V of X in my notes because that doesn't really help me remember what I'm doing. Okay, but if you remember that V of X is the manufacturing cost per item times the number of items produced, that's fine. Okay, I always use the cost function this way because I know what to put in because I see those words. Okay. All right, so you're going to take that V of X, which is the manufacturer's cost per item times the number of items produced, plus any fixed charges. Now, F of X makes sense for fixed charges. So the formula they give you right here, so the cost function equals V of X, which are these two things multiplied together, plus any fixed charges, okay? Again, you're going to see me writing this down so that we kind of know exactly what we're doing for cost. So this, remember, is actually a multiplication problem right there. V of X are these two things right here. That is V of X, okay? If that helps when you're looking at these problems or formulas. Okay, so cost is about the manufacturing of it, making it. Then we have profit. Profit, P of X, and this is your capital P. That's why I said the price is the little p. Profit is capital P of X, is the difference between the revenue function, how much they make, minus the cost function. That would make sense. So this company is making so much money, that's the revenue, but then they have to subtract the cost, what it takes them to make it, and that will give you your profit. So we already know what R of X is, we already know what C of X is, so we just subtract those two. Okay? Be real careful because the cost function is usually more than one thing. So remember, when you subtract, you're going to have to change multiple signs, so we'll talk about that when we get there. Okay? All right, lastly, number 5, the point where the revenue function equals the cost function. So how much they make versus how much they spend to make the items, that's called a break-even point. Okay, that's important in business to know how many things you have to sell in order to pay for the cost and break even, where you're not losing any money. So that would be where R of X equals C of X. So if you're asked to find a break-even point, you're just setting those two functions equal and you're going to solve for X. You can also solve for where P of X equals 0. That's exactly the same thing because profit, remember, was this minus this. Typically, you guys understand this a little bit better. So we'll stick with that, okay? All right, number 6 says, since the profit P of X is equal to 0 at the break-even point, that would be the Y value. The Y value is always going to be 0, so we only need to list the X coordinate of that point because we automatically know that break-even means the cost, the Y value is going to be $0. You made 0, you spent 0, okay? So when you're doing these problems and you're finding a break-even point, you just need to list X, okay? All right, so that's enough of all the formulas. So let's go through and work some of these problems, okay? All right, so number 1, first practice problem. Suppose that a company has determined that the cost of producing X items, so again, X is usually the number of items, is $73 per item plus a fixed charge of $5,780. Each item can be sold for $243. So the first thing we're going to do in this problem is find the revenue function. Okay, the revenue function. So remember, R of X, the revenue, equals, wrong page, the revenue function equals, I'm going to do it this way, the number of items sold times the selling price per item, right? So number of items sold times the selling price. And remember, your selling price can be D of X. Right? It might be more than just a number. It could be a function, depending if it fluctuates or not. In this problem, okay, our selling price How much are they selling them for? Is just $243. Okay, it gave me that. And I know that X is the number of items. So that means R of X equals X times 243. Okay. Now in algebra, we usually put that X in the back, so I'm going to write the revenue as 243X. Same thing. It's just a nice way to clean it up, okay? So if I sell 3 items, I would just multiply 3 times 243. That's how much the company is making, okay? The revenue. All right, let's look at part B. Try to keep this up here so you can see the information. All right, part B says find the cost function. All right, so let's remember what the cost function is. The cost function is the manufacturer. Oh, there we go, can't spell. Manufacturer price per item, right, times the number of items, which is typically your X, right, and then plus any fixed cost. That's C of X. And remember, in the formula on the top of this page, these two things is your V of X, right? So I don't like V of X because this makes more sense to you guys to see it. All right, so let's see what we got. So how much is the manufacturer price per item? Okay, per item, it's costing them $73. The cost of producing X items is $73 per item. So that is the manufacturer cost. So 73. The number of items is always X, and then plus any fixed charges. Well, the fixed charges is $5,780. Okay. So again, if we clean this up just a bit without all those parentheses, C of X would be 73X plus 5780. That's what we call the cost. That's the cost that is taking the manufacturer to make it. Okay, again, not the cost for the consumer. Okay, the consumer cost is the selling price. That's the consumer cost, selling price. Okay, moving on to part C. Find the profit. Trying to keep all this so we can see it. All right, so find the profit function. So the profit function, remember, P of X is the revenue minus the cost functions. And we already have those two up here. But we got to be careful with the minus. Okay, so that's why I want to make sure you're aware of this. So the revenue function is 243X minus, if your cost function is more than one term, put it in parentheses. So we're going to minus the cost function, which is this. Okay. All right. So we've got the revenue minus the cost function. All right, so if we're going to do this correctly, P of X then equals 243X. And then when you subtract a function, remember you have to multiply or distribute that negative sign through all of these terms. So both of these are positive right now. So if we take the negative of both of those, they're both going to turn into negatives. Right? That distribute. It's like a -1 being right there. -1 times 73 is negative 73X. -1 times positive 5780 is negative 5780. All right, and then we have some like terms here. So we can subtract 243 minus 73. They're both X terms. 243 minus 73 is 170. So P of X equals 170X minus 5780. That's the profit equation, profit function. Okay, so we have revenue, how much the company's making, cost, how much it costs the company, and the profit, how much they will make after we subtract those two amounts. All right, so now we got to find the break-even point. So remember, the break-even point is where the revenue equals the cost. Okay. So we're finding how many items does this company have to sell for them to not lose any money, but not make any either. Okay. Break even. All right, so R of X, okay, remember, is 243X. C of X, 73X plus 570. Oop, 5780, sorry. All right, so we got to solve that for X. So we're going to subtract the 73X over here. We know that's 170. We already did that. And then divide both terms by 170. So 5780 divided by 170. Okay. 5780 divided by 170. So 34. Okay, so what does that mean? Okay, we got X is 34. We know Y is 0 because break even is $0. Break even means they're going to earn and spend $0. So X is 34 units of whatever they're selling, right? So they have to sell 34 items before they're going to start making any money. When they sell the 35th item, then they're going to start making some money. Okay, so that's called a break-even point. Okay, not too bad. Okay, now in that problem, most everything was given to you. Okay, sometimes it is, sometimes it isn't. All right, so let's look at number 2. It cost Lynn $12 to build a picture frame. It cost her $12 to build a picture frame. She estimates that if she charges X dollars per frame, she can sell 40 minus X frames per week. Write a function for her weekly profit. Okay, write a function for her weekly profit. So make sure you're looking at what it is you're being asked to do, which is usually the last sentence. So profit is revenue minus cost, right? So I need to know the revenue function and the cost function before I can even find her profit, right? All right, so first things first, we need to find R of X, and then we need to find C of X, right? Once we know those, then we can do the problem. So we have to do these two things first before we can work our problem. All right, so remember what R of X is. Okay? R of X is the number of items sold times the selling price. All right, so let's go back to our problem and figure that out. All right, the number of items sold and the price. Okay, the number of items sold and the price. So this one you gotta be careful of. She estimates that if she charges X dollars per frame, so X dollars per frame is the selling price, right? That's not the number in this problem, so you gotta be careful. She charges X dollars per frame. Dollars. X dollars, that's the cost per frame. That's the selling price. So I know the selling price is X. All right, what about the number of items sold? Okay, she can sell 40 minus X frames per week. This is how many she can sell. That is the number of items. So that is 40 minus X. Okay, so you got to read the problem carefully. It's not hard, but you got to take your time with it. All right, so that means that R of X, if I were to multiply this, 40 times X is 40X, and negative X times X is negative X squared. Okay, so there's my revenue function. It's not my answer, but that's my revenue function. All right, cost. All right, let's remember how to do the cost. Okay, the cost function, remember, C of X is the manufacturer cost, right, Just abbreviate that, manufacturing cost times the number of items sold, plus any fixed charges. There may or may not be fixed charges, but that's the formula. Got to get used to these. There's only really 3 formulas, so make sure you know those. All right, so what is the manufacturing cost? It cost her $12. We already know the number of items sold is 40 minus X. And is there any fixed charge in this problem? It doesn't seem to be any fixed charge. So C of X is going to be the manufacturing cost, which is 12 times the number of items being sold. Okay, so if we multiply that out, 12 times 40 is 480. 12 times negative X, negative 12X. So there's C of X. All right. So now that I have R of X and C of X, I can now find my profit. Okay, write the function for her weekly profit. So P of X, remember, equals R of X minus C of X. So R of X minus, and then remember this goes in parentheses because you're going to have to distribute that minus sign through there. All right, so what does that give me? That gives me 40x minus x squared. Again, negative 1 times 480 is negative 480. Negative 1 times negative 12x is positive 12x. Okay, and now I can add some like terms. Okay, I've got 40x plus 12x, that's 52x, minus x squared minus 480. I can't do anything else with that, so that is your profit function. That is the final answer to our question. Okay, now you could write this in order. Some of you like to put the x squared first, so you could write negative x squared and then plus 52x minus 480. That is the same thing. Okay, as long as you have all 3 of these terms with the right sign in front of each term, you can write those any way you want to. Okay, all right. So that's the answer to number 2. All right, let's look at number 3. All right, the cost of producing 200 pens is $290. The cost of producing 250 pens would be $297.50. So the cost is changing, is fluctuating based on the number that we're producing, or the company is producing. Okay, so we have basically 2 points on this function that we're looking for. We have 200, producing 200 pens is going to cost this. Producing 250 pens will cost this. So notice it says find the average cost per pen. Remember, when you're doing more than 1 point, average is the same thing as finding that slope. Okay, so we have basically 2 points. 200 pens is $290. 250 pens is $297.50. Okay, because it says find the average cost per pen for additional 50 pens over 200. That sometimes throws off students, but basically the average cost. So we're going from here to here is what it's saying. That's 50 more pens. So what is the cost, the average cost from going from 200 to 250? Okay. All right, so we're going to do the average cost. So that would be the slope formula, basically. So we're going to subtract the y's. So 297.50 minus 290 over, subtract the x's in the bottom in the same order, 250 minus 200. Okay. All right. So 297.50 minus 290, that just leaves you 750. Over 250 minus 200 is 50. And we're going to divide 750 by 50. So that's 15 cents per pen, right? 15 cents per pen. Right. Okay. So that is the average price per pen from going from 200 to 250. Now, part B says, assuming that the total cost of this function is linear. That's important. You have to be given that. Write an equation for the cost of producing X pens. All right, so if it's linear, what that's telling you is the cost is constant, okay? Or the price, whichever, is constant, okay? So linear means no matter how many more I sell or how many less I sell, it's going to cost me 15 cents per pen. Okay, so that's a constant number. So that is the slope at this point. Okay, the change per pen is 15 cents. So how do I write a linear function? Well, remember it's y minus y1 equals m times x minus x1. That is the formula to find the equation of any line. And remember that average cost is the same thing as the slope. When it's linear, that is the same thing. We did that already. Okay, so that means I already know m. M is 0.15. And I already know x1, y1 because I already have two x's and two y's, right? So I'm just going to pick one of them. I'm going to use the top one that seems better. So I'm going to use this for x1 and this for y1. Okay, so y minus 290 equals the slope times x minus x1, which is 200. Again, this is x, this is y. So there's your y, there's your x. All right, so now we're just going to solve for y, right? The function, okay? The total cost function. So we're going to do c of x. That's what we're doing. So let's go ahead and finish this out so we can get the function. All right, so we got y minus 290. And now we're going to multiply 0.15 times x, 0.15 times negative 200. So 0.15 times x is 0.15x. Okay? And then 0.15 times negative 200 is negative 30. All right, now we're going to solve for y. So we're going to add 290 over to this side. Okay, so negative 30, and then we're going to do plus 290 gives you plus 260. So there is your cost function. So all we're going to do is instead of writing y, we're going to put in the notation for cost, which is that. Okay. So that is how much it costs this company to produce any number of pens. Okay, any number of pens. So remember what this is. Okay, think about the cost function. The cost function was the price per item times the number of items plus any fixed cost, right? So right there is your fixed cost. So remember that formula. So part C says, what are the fixed costs? Well, the fixed costs are $260. Okay. Now, another way to think of the fixed cost, remember, okay, just to think about it, remember that C of X, oh, that's not true, okay? The fixed cost is how much it's going to cost this company when they sell nothing. So this is the same thing as thinking about it is when X is 0. If they sell 0 items, anything left in my formula would be a fixed cost because I'm still going to have to pay that no matter what. So if this doesn't make sense to you with that formula, a fixed cost means you're selling no items. So let's find C of X. Okay, this is just another way to find this answer. If you understood that, you don't have to go through this. So if I let, I'm going to find C of 0, okay? So I'm going to do 0.15 times 0 items sold plus 260. Well, 0.15 times no items is 0. And 0 plus 260 is 260. So you still get that, just so you understand what a fixed cost means. Okay, again, I'm not changing the formula. I'm just saying if I don't sell anything, what's going to be left in this formula. Okay? All right. Let's look at number 4. All right, a manufacturer of color televisions can sell 800 sets to his dealer at $384 each. If the price goes to $380, so it comes down, he can sell 1,000 sets. So he can sell more if he lowers the price. Okay. The total cost of producing X television sets is C equals 3,600 plus 250x minus 0.01x squared dollars. Okay, so they're giving you the cost function. That's nice. They're giving you that X is the number of televisions sold. And then they gave us 2 sets of information about manufacturing. Okay? All right, so assuming that the demand function is linear, that's that word again, so that's about slope and the y minus y1 problems that we just did, write an equation for d of x. Okay, what was d of x? Okay, remember, this is the demand, which is the same thing as the price, right? Those are the same thing. Okay, the demand is not divided by, it's demand. D of x stands for the demand function, which is the same thing as the price. All right, and it tells me that this function is linear. So that means there's some ordered pairs involved. And right up here, they gave me those ordered pairs. If they sell 800 sets, that cost the manufacturer $384. If they sell 1,000 sets, it's $380. Okay? So notice they gave me that, and right there that's telling me I need to know what the slope is, and then I need an x and a y to put in my function. All right, so the first thing we're going to do is find m. Okay, remember that's y2 minus y1 over x2 minus x1, right? Same thing we did in the problem before. All right, so we're going to do 380 minus 384 in the top. Make sure you do them in the same order, 1,000 minus 800 in the bottom. Okay, so in the top, 380 minus 384 is -4, and in the bottom, I get 200. And if you divide -4 by 200, you're going to get -0.02. Okay, it is negative. And we know that because, look, the more I sold, the price went down. Right? So that would make sense that the cost per item is going to go down 2 cents per item. So that's what that negative sign means. The cost is dropping by 2 cents. Okay, so that negative sign has a purpose. All right, so then we can write the equation just like we did earlier. Okay, I'm just going to go ahead and use, it doesn't matter. 1,000 seems easier to work with. So I'm going to use this for x1, y1. You can use either point. Doesn't matter. You get the same exact answer. So y minus 380, I'm going to use that for y1, equals the slope, -0.02 times x minus 1,000. I only chose this point to use as x1, y1 because it's easier to multiply by. Really no other difference. You guys have a calculator, so this could have been x1 and that could have been y1. You'll get the same answer to work it out. Still use the same slope. All right, so multiply -0.02 times x, that's -0.02x. Multiply -0.02 times 1,000, that is +20. And then we're going to add 380 over to this side. So y equals -0.02x plus 400. 20 plus 380. And then it just says write the demand function. So we would just write, instead of y, we would write d of x. You're done at that point. You're just writing the notation. So there's the demand function, which remember, that's the price. That's the price of the televisions. Since it's linear, okay, that means there's no fluctuation. All right, now we're going to write the revenue function, okay, revenue function. Remember what the revenue function is, okay? It's the number of items sold times the price, right? Or D of X. That's D of X, remember the price. All right, so we know the number of items sold is X, and we just found the price, which is negative 0.02X plus 400. That's the price. So we just need to multiply that out. Okay, so we're going to distribute. X times negative 0.02X is negative 0.02X squared. And X times 400 is a positive 400X. So there is your revenue function. Okay. And lastly, the profit function. So remember, to find the profit, we're taking the revenue, which we just found, minus the cost, which was given to us in our information at the top. So first I'm going to write the revenue, which is negative 0.02X squared plus 400X minus, and then remember this goes in parentheses. I put a bracket, it could be parentheses, but C of X they gave you right up here. So we're going to minus that whole thing. That's the cost function, okay? So 3600 plus 250X minus 0.01X squared. I don't know why I use brackets. Parentheses is fine, okay? I wanted you to see them, I guess. All right, so we've got the revenue minus this cost function. So we got to distribute that minus sign through. So these first two terms will stay the same. But then we're going to change all these signs. We've got to multiply each of these by negative 1. So that's negative 3600, negative 250x, and then that last term is going to become positive 0.01x squared. Okay, and now we can add some like terms. So we're going to end up with, let's add the x squares. We got a negative 0.02x squared and a positive 0.01x squared. So just add those numbers. That gives you a negative 0.01x squared. You have a 400x positive and a negative 250x. Those add up to be 150 positive, 150x, and then the minus 3600. So there's your profit equation. Okay? Profit. Okay. I know I'm going slow on these, spending some time, but it really, you need to understand this before you get into section 2.9. So hopefully this is helping. All right, last one is pretty straightforward. Find the equilibrium point. Okay, the supply and the demand. So equilibrium is where they are equal to one another. Okay, means break even. So to find the equilibrium point, we would take 4x plus 7 and find out where that equals the demand of 72 minus 9x. Okay? All right. So now it says find the equilibrium point. So that means I need x and y. Okay, the whole point. All right, so solve this. So I'm going to take the negative 9x and move it over here. It's going to become positive 9x. So that's going to give me 13x. Plus 7 equals 72. That goes away. And then I'm going to take the positive 7 and move it over by subtracting it. So I get 13x equals 65. So I can now solve for x. Divide both sides by 13. 65 divided by 13 is 5. Okay, so that's x. But I need to find the point where everything is balanced. So how do I find y? Okay, how do I find y? All right, remember, function notation, is the same thing as y. So this formula right here can also be written as y equals 4x plus 7. That's the same thing, okay? And the same goes for d of x. I could write d of x as y equals 72 minus 7. That's function notation. We learned that back in chapter 1. So if I want to find y, and if these guys are equal, then I can really plug 5 into either one of these. It doesn't matter. I'm just going to choose the first one because that seems, smaller numbers always seem better to me. So I'm going to take the first equation, but I'm going to write it as y equals 4x plus 7 instead of s of x, just so I know that I'm looking for y. And I can plug 5 in for x. So 4 times 5 plus 7, and that's going to give me the function value, which is y. Okay, so 4 times 5 is 20 plus 7. So I end up with y equals 27. Okay, so my equilibrium point is 527. That's a point. Okay, so be careful. They didn't ask you just for x. And remember, for break even, that's different. We know that y is 0. Not on these when you're doing supply and demand. That's a little bit different. So pay attention. The fact that they ask you for a point, that means you got to give a point, x and y. Okay, so that should help you with your homework. Let me know if you need any help. Otherwise, work on that, and I'll see you back here next time.